Example 11. A circle C has this equation. The line L is a tangent to the circle and has a gradient of -3. Find two possible equations for L, giving your answers in the form y equals mx plus c. Let's start by drawing a diagram. We're going to draw this circle, then you know its centre and you know its radius. Its centre is at the point 5 minus 3, and its radius is the square root of 10, fractionally more than 3. So we can draw that circle, and look at that. I've drawn the circle, and here's my circle. You can see that it has a centre at 5 minus 3, and it has a radius of a little more than 3. I'm just going to write 5 minus 3 here, because that's the centre of the circle. Now, let's continue with our diagram. We've got to find the equation of the tangent to the circle, which has a gradient of -3. Let's draw that. So it's a tangent to the circle. It has a gradient of -3. So it's going to look something like that. Okay. And of course, there are two tangents to the circle, which have a gradient of -3. Here's the second one. There it is. And we've got to find the equations of these two green lines. Now, to find the equations of the green lines, we're going to need to know their gradients. Well, we know that the gradient of each of the green lines is -3. We also need a point on each of the lines. Well, here's a point on this first line, and here's a point on the second line. The question is, how are we going to find the coordinates of those two red points? Well, those two red points lie on the diameter of the circle that I've drawn there in red, and you know that that diameter is perpendicular to the tangents of those points. So I can find those red points by finding the points which lie on the circle and on the red line. Okay, so I need the equation of the red line. How am I going to get the equation of the red line? Well, I'm going to need a point on the red line. I've got that. And I'm also going to need to know the gradient of the red line. Well, I know the gradient of the red line is the negative reciprocal of the green lines, because the two are at right angles. So I know the gradient of the red line is -3. So now I can work out the equation of the red line. Y minus y1 equals m x minus x1. So I've got y minus -3 equals a third x minus 5. So I've got y equals x over 3, a third of x, minus 15. Sorry, minus 5 over 3. Take away 3, which is going to give me y equals a third x minus 14 over 3. So that is the equation of the diameter there. And to find the coordinates of the two red points, I'm going to need to solve that equation, the equation of the diameter, simultaneously with the equation of the circle to find points which lie on the diameter and on the circle. So the equation of the circle is x minus 5 squared plus y plus 3 squared equals 10. So I've got to solve these two equations simultaneously. Right, I'm going to do that by substituting in this value for y into my second equation. So I'm going to have x minus 5 squared plus a third x minus 14 over 3 plus 3 squared equals 10. Before I do any multiplying out, let's tidy this bracket up here. I've got a third of x minus 14 thirds plus 9 thirds is minus 5 thirds squared equals 10. Okay, x minus 5 squared is x squared minus 10x plus 25 plus a third of x minus 5 over 3 all squared is going to be a ninth of x squared. Now I'm going to have minus 5 ninths and another minus 5 ninths of x, so minus 10 ninths of x, and then minus 5 thirds times minus 5 thirds is plus 25 over 9, and that's going to equal 10 on the right hand side. Let's multiply everything by 9. 9x squared, 90x plus 225 plus x squared minus 10x plus 25 equals 90. Tidy up the left hand side. 10x squared minus 90x minus 10x minus 100x plus 225 plus 25 plus 250 equals 90. This is a quadratic equation. Set it equal to 0 by subtracting 90 from both sides. And now let's see if we can factorize it to solve for x. Well, before I factorize it to solve for x, let's divide by 10. Minus 10x plus 16 equals 0. Factorize it to solve for x. Both going to be negative. It's going to be 8 and 2. So the solutions are that x equals 8 or x equals 2. Let's just go back to our diagram. Remember what we're doing here. We're finding the coordinates of these 2 points. I found the x-coordinates of both of those points. So now I shall find those values of x into this equation here. So if x equals 8, then y will be a third of 8, 8 thirds minus 14 thirds, which will give me minus 6 thirds, which gives me a y of minus 2. Alternatively, if x is 2, then I'll have 2 thirds minus 14 thirds, which is minus 12 thirds, gives me a y of minus 4. So the 2 points where the circle and the diameter intersect are the points 8 minus 2 and 2 minus 4. 8 minus 2 and 2 minus 4. 8 minus 2 and 2 minus 4. So that point is that one, and that point is that one. So can I now work out the equations of my 2 green lines? Well, the answer is I can, because for each green line, I know a point on the line, and I know the gradient. Let's take this left-hand one first. I'm going to have y minus y1 equals the gradient, x minus x1. So my gradient is minus 3, and my point is 2 minus 4. So x minus 2 and y minus minus 4. Okay, so that's going to give me y plus 4 equals minus 3x plus 6 minus 4 from both sides is going to give me y equals minus 3x plus 2. And that is the equation of this line here. What about the equation of the second tangent? So I'll just highlight that one there. Now the second tangent is going to be, again, y minus y1 equals m x minus x1. My gradient of the second tangent is minus 3, of course. And the point on the line is the point 8 minus 2. 8 minus 2 is going to be x minus 8 there, and y minus minus 2, y plus 2 here. So that's going to give me y plus 2 equals minus 3x plus 24. And now I'm going to subtract 2 from both sides to give me y equals minus 3x plus 22. So that is going to be the equation of the second tangent. So there is my rather long solution to that example.